Boolean, in the sense, the first thing it comes to our mind, that is 0 and 1. Three logical operators, not, or, and. When it comes to NOT gate, the another name for the NOT gate is inverter gate. Hello everyone, I welcome all of you to the first session on Boolean logic. What is that we are trying to understand in this chapter, sir? It's going to be very important and it's going to be very interesting, my dear students. So what is that I have in this chapter? Let's understand that. So I will be discussing about what exactly is all about the truth table. So probably you would have come across with the truth table whenever you are doing a statistics problems. If you are not, so I will be explaining that from the scratch. Along with that, I will also discuss some of the logical operators. What exactly the logical operator is all about and how do we write the graphical symbol for each and every logical operator. Along with that, I will also explain the truth table for each and every logical operator that we have. So after that, I will also discuss about the evaluation of Boolean expressions. How do we evaluate the Boolean expressions is what I'm going to discuss in this session. The most important thing that you have to know is basic logic gates. When it comes to basic logic gates, so my dear students, please understand, if we speak about the logic gates, we have two categories of logic gates. One is basic logic gates, another one is derived logic gates. So what exactly basic and derived logic gates? So basic logic gates is all about, like all of you know that, and, or, and not. So, and I have derived gates. So that is derived from this basic gates. So in this session, I will be discussing the basic logic gates along with the truth table and graphical symbol for it. So without wasting much of your time, hope all of you got to know what is that I'm discussing in today's session. So let's start the session for all of you. So guys, what exactly Boolean algebra is all about? So when it comes to Boolean algebra, please make a note of it. It mainly deals with the values that is true or false. It mainly deals with a value that is true or false. So what is true, what is false? Boolean, in the sense, the first thing it comes to our mind, that is 0 and 1, zeros and ones. Yes. What is 0 and what is 1? Please understand, whenever I'm mentioning it as true, I will be using 1. Whenever I'm using it as false, I will be using 0. So that's what you need to understand. So I always represent true with the 1 and false with the 0. So that's the main important point that you have to remember before I start the Boolean algebra. Alright, so the second point says the same thing. Each question will have two answers. So please understand yes or no. That's what they are trying to say with a true or false. So true or false, in Boolean algebra we use 1 for true and 0 for false is the second point that you have to remember, which we have already discussed. So this is the basic thing. Before we start this topic, you should know. So fine, sir, what is the next thing that we need to understand? Alright, I have the truth table. You understood what is 0 and what is 1. You understood when we have true, we use 1. When we have false, we use 0. So how do we represent that with the truth table? What exactly truth table is all about? So that's an important thing that you need to understand now. Let me give you a brief knowledge with respect to the truth table. Say for example, I have two inputs. How many inputs I have? Two inputs. So when it comes to input, imagine I have A and B. How many inputs I have? I have two inputs. So for this two inputs, I will have one output. So let me assume that I will consider the output as F. So for this, I need to write the truth table. So how do I write? So let me assume A is one input and B is one input. Alright. So for this A and B, I will have F as the output. This is the basic thing that you should understand. So fine, I will have this column. Alright. So then how do I write the input combination for this? How many input combinations will I have for this? It's a very interesting thing that you have to understand here. So how many inputs I have? So I have two inputs. So if you have two inputs, so basically we are dealing with the binary numbers. So that's the reason I will take 2. So how many inputs you have? I have 2 inputs. So I will raise the power 2. So 2 to the power of 2 is how much? So you will have 4. So I should have 4 combinations of input. I should have how many combinations of input? 4 combinations of input. Sir, we did not understood, sir. What did you say, sir? We should have 4 combinations of input. So please understand, please listen to me now. I will explain it very clearly. So how should I take 4 combinations of input? So that's a very interesting fact. That's a very interesting thing that you should understand. And it's very simple also. See, for example, if I take any number, I should take the number in the form of zeros and ones. That is the first condition that you should know. So fine. I will be writing 0, 0, 1, 1. Always my combination will start with the 0, 0, 1, 1 when it is 4 combinations. How many numbers you have? 4. How many numbers you want? 4. So fine, 0, 0, 1, 1 you have written. Then next, when it comes to B, what is the input that you are writing? So I will write 0, 1, 0, 1. So did you got 4 combinations of zeros and ones? You check out. So I have written 4 combinations of zeros and ones. It's an easy way to write the 4 combinations. Otherwise, you will mess up yourself in writing. So please follow this method. This will be very convenient and easy method that you can write. All right. So whatever the operations that you are performing, that output. So it will give you the output. The respective output you will start writing here. All right. So this is what I will call it as a truth table. This is what I will call it as a truth table. Somebody will ask me, sir, you have considered you have 2 inputs. Yes, I have considered 2 inputs. What if I have 3 inputs? So how exactly my truth table will look like? So that's an interesting fact that you need to understand. So let me explain that too. All right. So remember, obviously, I'm dealing with zeros and ones. So it's a binary number. So I will have to consider 2. So how many inputs you have? You have A, you have B, you have C. So this is my inputs. So I have 3 inputs. So obviously I will write 2 to the power of 3. When I have 2 to the power of 3, so what should be the result? I should have 8. 2 to the power of 3 is 8. So I should have 8 combinations of input. So how do I write, sir? It's very confusing and it's very messy thing. How do I write 8 combinations of input? So it's very confusing thing. So is there any shortcut? Yes. What we have followed in the previous one, the same thing, but listen to me carefully. So we started with 2 zeros and 2 ones, right? So let's start with 4 zeros now. How many zeros I should have? 4 zeros in the beginning, 4 zeros in the next end, right? So I have 0, 0, 0, 1, 1, 1. So I'm done with A. Then what is that I have to do with B? So I have 4 zeros here. So I have to write 2 zeros instead of 4 zeros. 2 zeros, 2, 1. 2, 0, 2, 1. All right. I think you will guess the next pattern. Obviously, yes. 0, 1. So here I had 4 zeros. Here I had 2 zeros. Here I have 1 0. So it changes from one input to another. So you keep writing 0, 1, 0, 1, 0, 1. So this is how you will be writing. And you can also write the output. Obviously, it will be only 1. That's what you have to remember, my dear students. All right. So fine, sir, we understood for 3 variables. Then how about the 4 variables? It's very simple. So I have told you, I have given you the formula. So if it is 3, you will calculate 2 to the power of 3. If it is 4, simple, 2 to the power of 4, it's 16. All right. So here you have 4 zeros. So when it goes to 2 to the power of 4, you will make it double. That's it. All right. So 8 zeros, 8 ones. The same thing, you will keep on writing. All right. So this is the method that you have to follow whenever you are writing the truth table. So I have given you the basic knowledge to understand how to write the truth table now. So fine, all of you know the truth table now. All right, moving on to the next one, I have logical operators. What exactly logical operator is all about? My dear students, we have 3 logical operators. The first one that we have is not. What is the first one that we have? We have not, and the second one that we have is or and and. So we have three logical operators, not, or, and. So we all know that what exactly or, not, and is working. So let's understand this logical operator in detail. So let's start with the not operator. Let me not discuss the graphical symbol right away. Let me show you the functionality with the help of truth table. So assume that I have a not gate with me. So that is what I will call it as a not operator. So for not operator, so it is important that you need to understand how many inputs I will have. When it is a not operator, please understand, when it is a not operator, it is very important that we need to understand what is the minimum number of inputs that I will have and what is the maximum number of inputs that I will have. So please understand, I will have only one input when it comes to not operator. Please understand this point. This is very, very important. So fine, we understood that. So that input, I will consider it as X. My input, whatever I'm taking for the not operator, that is what I am treating it as X here. So fine, I have X. So how many numbers I have? 0 and 1. So for both 0 and 1, I will take it as input. All right. Whenever I take any input, so please understand, I'll just move out of the frame and I'll explain this table for all of you. So please listen to me. So I have 0, okay? I have 1. I have 0 and I have 1. So I need to know what exactly will happen to the 0 and 1 when I pass as an input to the NOT gate. That's what you need to understand now. So please understand, I have 0. So I will be using NOT gate when I pass 0 as an input. So that will get converted or that will get complemented into 1. So that's very simple. NOT gate in the sense, if I pass this, my output will be this. If I pass this, my output will be this. That's very simple. This is 0 and this is 1. Alright, I'll repeat. If I pass this, my output will be this. If I pass this, my output will be this. It's very simple. Alright, so if I pass 0, my output will be 1. If I pass 1, my output will be 0. As simple as that. That's what the NOT gate is all about. But how do I represent it, sir? So please understand X dash. Please understand X dash. I have X as an input. So X dash is what I will call it as a complement of X. X dash is what I will call it as a complement of X. That's what you need to understand here. Alright. So you understood about the NOT gate. So it's very simple. If you pass 0, you will get 1. If you pass 1, you will get 0. If you pass male, you will get female. If you pass female, you will get male. Is it? Not like that. Alright. Moving on to the next one. It's pretty simple, right? I have OR gate with me, OR operator. Let me not use the word gate here. So what exactly I have here? So I have how many inputs? I have 2 inputs. When it comes to NOT gate, please understand I had only 1. So when it comes to NOT gate, I should take only 1 input. I should take only 1 input. But now when it comes to OR gate, it's important that you need to have minimum 2 inputs. You need to have minimum 2 inputs. So I'm writing the truth table assuming that I have 2 inputs. Alright. So my inputs is X and Y. That's what I have mentioned it in the table here. Okay. So you also know that how did I wrote this values for this truth table. So how many inputs I have? I have 2 inputs. So if I have 2 inputs, 2 to the power of 2 is 4. So I have to write 4 combinations of zeros and ones. So how do I write? So first I will write 2 zeros and then I'll write 2 ones. That's what you need to understand, right? Then after that, 0, 1, 0, 1. That's how you will write this combination. So you got to know how did I arrive at this truth table values. Then what is the result? When it is OR, please understand. So when it is OR operator, you need to understand that is addition. That is addition. So what is that I'm performing? X plus Y. Alright. What is that I'm performing? X plus Y. So I have 0 plus 0. What is that answer? 0 plus 0 will be 0. 0 plus 0 will be 0. In the previous class, we have discussed the binary addition. Yes or no? Yeah, we have discussed the binary addition in the previous class. So I think all of you will be knowing this, but let me just repeat the same thing. So 0 plus 1 will be 1. All right. So you have 1 plus 0. So you will get 1 again. When it comes to 1 plus 1, so please understand it's 1. Why it is 1? Because the sum is 0 and the carry will be 1. The sum is 0 and the carry will be 1. So this carry, I'm retaining it here. So that's how. So I have got 1. So that's what you need to understand, which we have already discussed and which we know it properly. All right. So moving on to the next one. So I have AND operator. So how do I use this AND operator? What is the operation that I have to perform when it comes to AND operator? So obviously, when it is OR, so please understand, when it is OR, we perform addition. We perform addition. But when it is AND, so we perform AND gate, that is multiplication. We perform AND gate, that is multiplication. So this is what you need to understand. The same thing I have performed here also. So please understand, I have two inputs which you already know about it. All right. So you know how to write the truth table. Same thing what I have done in the OR gate. The same thing I have taken. All right. So why I have taken the same thing? Because it's a two inputs, right? So it does not matter what gate I'm dealing with. All right. So I have X into Y. X into Y. So I have to perform this operation. This multiplication is what I will call it as a AND gate. This is what you need to remember. I have 0 into 0. So what is that I have? 0 into 0. Obviously, it is 0. All right. So 0 into anything is 0. So directly I will just write wherever I have in any one column. If I have 0, directly I will just write 0. And I have 0 here. So I will write 0. So only one column I have. Only one row I have. 1 into 1. So I will write 1. All right. This is the output if I perform AND gate. All right. So moving on to the next thing. So imagine they have given this expression. They have given this expression and I need to calculate. I need to prove this using the truth table. How do I do this? So let's understand. It's very simple. So let's try and do it. All right. So how many different variables I have? I have X. And what is the different other variable I have? I have Y. So how many variables I have? I have two variables. So when I have two variables, 2 to the power of 2 is 4. So I should have 4 combinations. So do I have 4 combinations? Yeah. Yes, I have 4 combinations. That's very simple, which we have already done. All right. So fine. I have X and I have Y. I know the value of X and I know the value of Y. But let's start with this expression. So do I have the X value? Yes, I have the X value. But do I have X into Y value? No, I don't have. So let's write that. We need to calculate X into Y. Let's start doing it. So X into Y, in the sense I have to perform AND operation. And in the sense what? Multiplication. 0 into 0 is 0. 0 into 1 is 0. Again, 1 into 0 is 0. 1 into 1 is 1. So I got X into Y. Then do I have X plus XY? You got XY, right? So what else do you want for this expression? Do you have X plus Y? No, I don't have X plus Y. So let's calculate X plus Y. Let's calculate X plus Y. So this is XY. Okay, this is X. Let's perform the addition for these two. Let's perform the addition for this two. So please observe, 0 plus 0 is 0, right? Hope you are able to see this. 0 plus 0 is 0 plus 0 is 0. I'm performing the addition operation. I'm performing addition operation. Why? Because I have plus operator here. All right. So 0 plus 0 is 0. Please understand, 0 plus 0 is again 0. All right. So again, I have 1 plus 0. I have 1. So you already know that. That's how we perform the addition. All right. So we have 1 plus 1. Obviously, the result will be 1. So fine, I understood how to perform. Now let's check whether it is equal. So this expression and this should match. Is it matching? Let's check that. So this is X into Y and this is X plus Y. Okay. Let me just write this as 2 and this as 1. All right. So this is 2 and this is 1. So compare this 2 and 1. So do I have the same values? So please observe here, 0, 0. Yes, I have the same thing. 0, 0. I have the same thing. Here I have 0 and 1. So it's not same. Right? So here I have 1 and 1, it's same. But here it's not same. So this equation is not equal. This is how we perform the operation, or we execute the expressions into truth tables. This is what you need to understand. The only thing that you should have in your mind, like, how do I write the truth table for the given expression? This is what you need to understand. I think this is pretty much simple for all of you to understand. So moving forward, so I have basic logic gates. So we have already discussed and, or, not. What is that? And, or, not is the basic logic gates that we have. Let's understand with the graphical symbol. So guys, let me start with a NOT gate. When it comes to NOT gate, the another name for the NOT gate is inverter gate. Okay, so the graphical symbol for the NOT gate is this one. Please understand the invert triangle. So you should write the NOT in front of this. So please understand, it's very important that we need to notice here, I will be able to pass only one input. If I pass one input, the output of this input will be the complement of the input. All right. So this is how we have written the truth table also. So here I have input A and I have input B. I can also write it as X and X dash. X and X dash. If I pass 0 as an input, my output will be 1. If I pass 1 as an input, my output will be 0. That's what I have represented with the help of truth table. So it's important that when it comes to the gate, you should remember the definition, you should remember the graphical symbol, and you should remember the truth table for all the gates. So this is the NOT gate for all of you. So moving on to the next gate, I have OR gate. When it comes to OR gate, we all know that we perform the addition operation. So when it is addition operation, so please understand, so this is the graphical symbol that you use to represent the OR gate. All right, so I have two inputs, so A and B. Let's imagine like this. Sir, do I have only two inputs? No, I can have more than n number of inputs, but minimum I should have 2 inputs is very, very important. All right, I have 2 inputs with me, and I will represent F as output is what you can write. Okay, there is no hardcore rule that you have to use the same naming conventions. You can take your own naming conventions is what I would like to tell you at this point of time. Say for example, I have taken A, B as a input in the truth table and Q as an output here. All right, so you all know how do I write the truth table if I have 2 inputs, right? So I have written 0, 0, 1, 1. So what is this gate? This is a OR gate. So what operation I have to perform? Addition. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 again, and 1 plus 1 is 1 again. So guys, this is the truth table of OR gate. This is what you have to remember. Again, when it comes to OR gate, you should remember the definition. You should remember the graphical symbol. This is what we will call it as a graphical symbol. They also call it as a traditional symbol, but mainly we call it as a graphical symbol of OR gate. All right. So the last gate that we have is AND gate. So this is how we write the graphical symbol for AND gate. So here also minimum I should have 2 inputs. Maximum I can have n number of inputs, more than 2, right? So let me just consider my input as A and B and output as Z, right? So this is the graphical symbol of AND gate. Whenever I say AND gate, so what is the operation that will come to your mind? Of course, it is multiplication. It will perform multiplication. So you all know that same truth table. So how to write the truth table for 2 inputs? You all know that, which we have already discussed in the beginning of the session. So please understand 0 into 0. So why into sir? Because this is AND gate, right? So 0 into 0 is 0, 0 into 1 is 0 again, 1 into 0 is 0, 1 into 1 is 1. So my dear students, this gives you a basic brief knowledge with respect to the different logic gates. Along with that logic gates, you also understood, you also came to know what is the different logic gates graphical symbol and how do I write the truth table. So you understood how to write the truth table for each and every different gates, but I also taught you how to write the truth table for the given expression. So that's what you need to understand. So guys, so with this, I conclude my session. So I have some interesting topics in the coming sessions. So keep waiting, and if you have liked it, if you have understood the topic, don't forget to click on the like button and take care of yourself. Thank you, everybody.